Hi there, I welcome you all in my first episode of the video series called AC Power. As you can see, the title of this episode is AC vs DC and AC in a sinusoidal form. So, the things we are going to learn in this video is the first one is the basic understanding of AC while comparing it with DC, and the second is the different form of AC. While from all of these form of AC, the most abundant form of AC is sinusoidal form. So we will study that why sinusoidal form of AC are more abundant. In such a way, even if you notice that in your house you have a different electrical socket and you extract an electrical power or alternating electrical power from that socket. This power is produced from alternating current and alternating voltage. If you analyze this alternating voltage and alternating current in oscilloscope, you will come to the point that these voltage and the current are in a form of a sinusoids. So why you didn't get a triangle form or a rectangle form of AC current or voltage in your household sockets? We will study the reason because of a reason about this aspect in later slides. So this is our first slide of this video series, AC and DC. DC, as by the name implies, DC stands for direct current. From the direct current you can conclude that its amplitude always remains same. Its amplitude doesn't change with respect to the time. So it is also called a time invariant, meaning it doesn't depend on the time. So it's time invariant current having a constant amplitude throughout the time. It's a direct current. Alternating current have a varying amplitude with respect to the time, so its amplitude change with respect to the time, so it depends on the time, so it's a time variant current. And now the most important thing to define the definition of alternating current is this name, alternating. The word alternating is derived from a word alternate. The alternate mean occurs in turns. In order to explain this and this point, periodically reverse the direction, I have to consider this image. For example, for a time being, consider it's a current, it's not a voltage in y-axis. So you can see the current is moving in one direction in some specific time period from 0 to 1 second. But after a 1 second you see that it's not positive, it's get negative, and the negative current mean it's moving in a different direction as compared to the one it is moving at the beginning. So it's moving in opposite direction. But you can see or compare that its behavior at the positive direction and the negative direction is same, and it has again the same behavior in positive direction after this time period. So from the start, alternates mean occur in turn. For example, this is the turn of the first half wave, this is the turn of the second half wave. The first half wave occur in some time period, and for other time period the second half wave occur, but it start repeat itself. The first half wave come and it repeat, second half wave come, it repeat. So alternate is mean doing in turns, the two waves are repeating itself in turn, but they are repeating in some specific time period. For example, 0 to t is the one time period. The two half wave of this whole wave repeat itself in this time period, and for the next time period it will repeat their self again. So these things, but remember in this specific time period it occur in turn. The first wave have first run and the second wave have a second run. So that's why it's called alternating current. It's alternate in some specific time period. It's alternate mean the first one come first and the second come first, and it repeat in the other time period. So that's why it is called alternating. And you can also say it's a periodically reverses direction, have a periodically reverses direction. This is the one time period and it changes direction in this time period, and this time period is same as compared to this time period. For example, if it's 0 to 1 second, then it should be 1 to 2 seconds. So it's opposing or it's changing in direction after a specific or the same time period. Okay, so these are the 2 points, and that's this behavior. Because of this behavior we call alternating current. So any current which is called an alternating current should have a three characteristics. The first, its magnitude should be changed with respect to the time continuously. The second, it should alternate in a some specific time period, okay, or have a same time period they are alternating. And the third, it's periodically reversing the directions. It's periodically reversing the direction, so that's why it's called alternating current. So there are different form of alternating current. AC current, they are triangular form, rectangular form, sinusoidal form, but the most abundant form of an AC current is sinusoidal form. Why? The alternating current is sinusoidal form because of many main reasons. We will see these reasons in our next slide. These are AC in form of sinusoidal. The first reason is it's easy to generate and transmit. As you know that the conventional generators are built in such a way that they output an alternating current and voltage, out of which we produce alternating power. So in order to generate an alternating current with a different waveform in a very heavy scale, then you have to build either a power electronic device, or you have to build a generator with a new design, not the one which are being used or the conventional generator. So it's very difficult. So it's very easy to generate and transmit the sinusoidal form of an AC current. The second is analysis get easy with sinusoidal form of AC. So this, I will say that this is the main reason why the AC is always be preferable in sinusoidal form, not triangle, not rectangular, or not any other, because only of analysis. These are main some points which are supporting this analysis one's point. The first is the dominant form of signals in communication are in sinusoid. So the laws and the method that you are applying in the field of communication to analyze a signal in form of sinusoid can be applied in the power system to analyze an AC current and AC voltage. So it's become easy. The second is the most of the nature aspects of the nature follow the behavior of sinusoids. For example, the simple pendulum. Simple pendulum rotate about its mean position, and it follows the same behavior as the sinusoids does. So the formulas and the method that you are using to analyze the sinusoidal behavior or can be applied to a pendulum or vice versa. And the third is Fourier analysis. As you know that in Fourier analysis we represent a signal in the summation of different form or different frequency of sinusoids, or in different harmonic frequency of sinusoids. So the Fourier analysis can also be used in analyzing the sinusoidal form of AC. So it make more easy to analyze it. The fourth is the derivative and integral of sinusoids as sinusoids. So it's also the one of the point that is supporting that by using the AC in form of sinusoid, our analysis become more easy. The whole point of this thing is that an AC current is always be in form of sinusoid, because their analysis become more and more easy to keep them in sinusoid, either producing an AC or using an AC in form of triangular or rectangular. Then the analysis will be more difficult, and we can't apply the conventional method we are applying to solve sinusoids to that. So that's why we always use a AC in form of sinusoids. So that was the end of this episode, or you can say this video of one of our video series of AC power. So we will meet in our next video, which will be the sinusoidal analysis vs sinusoidal phasor analysis.